Today we discuss about the abrasive jet machining process. This process comes under the mechanical processes groups, in which all the groups comes under the non-traditional abrasive machining processes. Okay, these are just short classifications of the non-traditional machining process. Abrasive jet machining processes. In abrasive jet, particles are made to impinge on work material at very high velocity. The jet of abrasive particles is carried by gas or air and impact the small abrasive particles on a workpiece to remove the materials from the metals. A high velocity stream of abrasive, not a single abrasive, multiple abrasives called as you can take the powders of the abrasives with gases to generate a jet. This jet are impinge on the workpiece to remove the materials. Okay, this abrasive is generated by converting the pressure energy of the carrier gas or air to its kinetic energy, and hence high velocity jet is formed. These jet are used as a tools to remove the material from metals. The high velocity abrasive particles remove the material by micro cutting action as well as the brittle fractures of the work material. So just like ultrasonic machine process under the brittle fractures of the metals. Then we can remove the materials from the metals by the erosion processes. Okay, this is short descriptions or short introductions of the abrasive jet machine process. And clearly the process working on abrasive particles. These abrasive particles impacted on workpiece and remove the material, because the abrasive particles having the sharp edges. The sharp edges are used to remove the material to make a micro cutting actions on the metals. Okay, generally for this we use brittle materials are majorly used for machining. The principles. Each and every process having their own principles, because each and every process having their different types of energy uses to remove the materials. In abrasive jet machine processes, use a mechanical energy to remove the materials from the metals. Thus, the abrasive works on basic principle of the abrasive erosions. Okay, you say here the abrasive erosion processes is called as abrasive erosion processes, or the method of the remove the materials from the materials is called as abrasive erosions, not called as simply just like your single button cutting tools or removing the material from materials in the form of the chips. There is generally this machine process are the abrasive micro or tiny particles are removed in the machine. So these abrasive particles, when you remove the material, but this abrasive particle doesn't have any geometry. So the major principle or main principle is that we first break or we first crack the materials. They're called as the brittle fractures of the materials. So if high velocity abrasive particles strike on the hard or a brittle workpiece, it removes metals at the striking surfaces. The metal removed due to brittle fractures of the metals, and also due to micro cutting actions of the abrasive particles. So figure shows the principles of the abrasive jet machine processes. Here is gas and abrasive particles with a velocity of near about 300 and more 300 meter per second into the one nozzles. That is, the nozzles are used to generate the jet of the abrasive particles. Okay, these nozzle having proper shapes, I mean internal diameters. The internal diameter near about the nozzle of is near about 0.18 to 0.8 mm only. And the second major factors for this principle of this is the distance between the nozzle tip to the workpiece is not more than the 2 mm. Okay, this is called as the standard distance of 0.3 mm to 2 mm. Above the 2 mm, they go on machining, but not give the perfect accuracy for the machinings. Okay, All the abrasives comes from this nozzle to form one jet between this standoff distance, and this jet has impacted on the workpiece surfaces. The workpiece surface goes under the brittle fractures. The abrasive makes cracks on the surfaces, and the abrasive also remove the material in the form of the abrasive erosions. These are the working principles for the abrasive machining processes. Okay, then what are the components for the abrasive jet machining processes? The figure shows the working setup of the abrasive. In that there is a gas containers, filters, and the mixing chambers, or the power supply and mixing chambers, where is the abrasive particles or abrasive powders and the gas from the gas are mixed together in a chamber or mixers, and after that they can transfer to this hose pipe to the nozzle, and nozzle is directed towards the workpiece surfaces or the metal surface where you want to machine it. But here is one of the important parts for the abrasive is called as a hood and exhaust, because the abrasive particles are little bit hazardous to the human life, so you can collect this or you can exhaust it properly. So these are the part for the component of the machining. So high velocity jet of dry gas, nitrogen and carbon. One of the, you notice that is not only the gas, but you can use nitrogen and carbon dioxide also to carry the abrasive from this mixing chamber to the nozzles to make a velocity about the 300 or more meter per second for the machining processes. The parameters. You see in ultrasonic machining processes, there are some parameters. Generally, we discuss the parameter is called as the input parameters. First, what are the because each and every process having some inputs, then these inputs comes under the processes, and then we generate outputs. So the output is called output parameters, but input is required. What is the process? Process is called as abrasive setups. Then what are the inputs? Inputs are called as the inputs are first abrasive particles. The major inputs. When we change the abrasive particles, you can change the output of the processes. Okay, and what are the different types of abrasive? The composition of the abrasive near about the silicon carbides or aluminum oxides, and this mass flow rate for the abrasive, again the important rate, important factors for the parameters. Second parameter is called as the gas carriers. Okay, not use single oxygens or airs, but we use also the nitrogen and the carbon dioxides with the pressure of the 2 to 8 bars and the temperature and the temperatures and velocity near about 300 to 500 meters per seconds. Third parameter is the nozzle. Nozzle is one of the important parameters because the nozzle generates the jets. Those jets are used to remove the material. All those jets impact the abrasive particles on the workpiece surfaces to remove the materials from the metals. Okay, so nozzle is one of the important because nozzle generates these jets. These jets are very important because the distance between these tip nozzle tip to workpiece, one of the important characteristics for the abrasive machining processes. The nozzle having the different types of materials, the tungsten carbide and the sapphires. Mostly the sapphires are used because sapphires having the good life. Near about the 300 hours of the sapphires lives only. Tungsten carbide having the very low lives because these abrasive particles when comes across from these nozzle holes, at that time they also continue the micro machining on nozzles also, and the nozzles get eroded or nozzles get depleted. Okay, then fourth is called as the abrasive jet. It is generally called as the standoff distance. When we change the standoff distance, we can change the output. That's why it is the parameters. Okay, and last one is called as workpiece material. Which types of workpiece material? What are the mechanical properties of the workpiece? Generally, they are mostly affect the two properties. First is called as the ductility, and second is called as the brittleness. When the material is ductile, then output is going to be changed, and when we go for the brittleness, output is changed. So then this machining process use these are non-conductive hard materials or brittle materials like glass, ceramics, and other brittle materials are easily working on this machining process. These are the general called as the aging parameters or input parameters. First is called the abrasive particles, carrier gas, nozzle, abrasive jets, and workpiece materials. What are the characteristics for the agents? The first characteristic is the machining for very hard material easily on the average jet machining processes. There is no heat damage to the workpiece by the HM processes used to cut the material that are heat sensitive. If material is heat sensitive, at that time we use the HM processes than the other processes because this process is very good. Okay, and but it's having one of the small disadvantages. It cannot produce the deep pull because it produces taper shapes. When the distance, this is called a SOD or stand-up distance increases, the taper shapes are produced by this abrasive jet materials. Okay, these are the. And what are the output characteristics? Okay, this output characteristics comes under in the output characteristic is the metal removal rates. Then here are 4 to 5, 3 to 4 output characters are there. One is called as metal removal rate, second is called surface finish or machining accuracies, and then the surface finish is called as surface roughness for the processes. These are the outputs. Then geometry of the cuts. Which types of geometry you can produce. And last one is called the nozzle lives. Nozzle life is one of the important because these are again the output when the abrasive comes under the abrasive goes from the nozzles, then nozzle get eroded. So this again the output character for the processes. Called as when the limit goes about the 1.5 to 2 mm, removal rate goes on decreasing. These are the impact of the input parameters on the material removal rates. Okay. What are the general key points of the aging processes? First is called as is similar to the sandblasting. Second is called as remove the material through the eroding actions. Okay, these are eroding actions. Brittle fracture and erode the material from the workpiece. Okay, gas is first compressed and mixed with the then mixed with the abrasive particles and in a mixing chambers and pass through outlet nozzles. Next, computer is used to position the jets. It is not a manual process. It is a computer processor, computer numerical control processes. Okay, gas pressure about the 7 atmosphere pressures. Then velocity of the jet is near about the 300 meter per second. Jet diameters is generally 0.12 mm to 1.25 mm. Abrasive used. Most of the Al2O3 abrasive or silicon carbides are used with the particle sizes near about the 10 to 15 microns. So it is small particle, just like a dust or powder form in the powder form. Tool materials is a tungsten carbide sapphire. It's called as a tool is called as a nozzle materials, and nozzle life is near about the 30 hours for these sapphire levels. These are the general key points for the aging processes. Agent, what are the advantages of the agent processes? Can we use in any materials, conductive or non-conductive, ductile and brittle material? Any types of material they can use by this for the agent processes. Good dimensional accuracy can be achieved near about the 0.05 mm plus minus are achieved by using the agent processes. Good surface finish also achieved near about the 1.25 micron levels. Due to cooling actions of the gas stream, no thermal damage. Okay, this cooling, these are the major role for the gas streams. These gas streams are used for the cooling or coolants in this processes. So no thermal damage on the work surface. Due to negligible workforce, delicate workpiece can be easily machined, but this process having other disadvantages called as low MRR, possibility of stray cuttings, embedded of abrasive particles in a soft workpiece, and dust control needed. These are the major disadvantages of the AGM processes. Is called general use of fine drilling process, machining of semiconductors, abarding of gas particles, and cooling on metals, machining of the metal lights. Okay, these are about the AGM processes. Okay.